Before I start with the notes for today, I'm going to give you some more math humor. And it's a riddle. Why do other numbers refuse to take square root of 2, square root of 3, square root of 5 seriously? So just send me the answer to that riddle in Schoology, and the first person will get a prize. All right, today I want you to be able to use slope-intercept form and point-slope form to write linear functions and also to write linear functions to solve problems. So we're going to start out writing equations for lines in point-slope and slope-intercept form. Hopefully you remember that from Algebra 1 and also from geometry. The first problem involves a graph, and you have all the information there that you need in order to write the equation for a line. If we're writing it in slope-intercept form, the name tells you what you need. You need the slope and the intercept, the y-intercept. So if we look at this graph, we can find the slope by going vertically in the vertical direction and then horizontal, because it's y over x for slope. The change in y over the change in x, I should say. So we have the change in y is 3, the change in x is 4, so our slope is 3/4, and then if we trace up here on the y-axis, we can see that that line crosses the y-axis at 0, 3, so the y-intercept is going to be 3. And that's all you need. You just substitute those values in. Slope is 3/4, the y-intercept is 3, so when we're looking at y equals mx plus b, we substitute our slope in, which is 3/4, and we substitute our y-intercept, which is 3. All right, now we're going to go to the other side. Question number 2, you're given a slope and a y-intercept. So that's even easier than question number 1. We have everything that we need. We have a slope of 5, a y-intercept of 3. So here it's written in as a linear function. We have f of x equals mx plus b. The slope is 5. M gets replaced with 5, and the y-intercept is 3, so b gets replaced with 3. So pretty easy for that one. Now we're going to look at writing an equation in point-slope form. So the name of the forms tell you what you need. When you write an equation in point-slope form, you need a point and you need a slope. When you're slope-intercept form, you need a slope and an intercept. So let's see what we have to start with here. We have point-slope form looks like this. Y minus y sub 1 equals m times x minus x sub 1, where x sub 1 and y sub 1 are an ordered pair. Okay, so what information do we have? We have a table. Well, we need a point. We have lots of points to choose from, and we need a slope. So the first thing that we need to do, be concerned with, is finding a slope. And you can choose any 2 points in the table to find a slope. I just circled the first 2, and it doesn't matter. You'll get the same slope regardless of which 2 points you pick. So the y's go in the numerator, so 5 minus 2 over 8 minus 4, and that's going to give you 3/4. So that's our slope. Now we need to choose a point, and you can choose any point you want. I'm going to just choose, let's see, what point did I choose? 4, 2. So that represents x sub 1, and that's y sub 1. All right, now when we write the equation for the line, we can say, we'll just put this is y sub 1 goes here, so that would be our 2. And there's a minus here from the original equation. And then we have our slope, which is 3/4. And then we can say x minus x sub 1, which is x minus 4. So there's our equation for our line. We have y minus 2. Now if we distribute this, we're going to end up with y minus 2 equals 3/4 x minus 3. And you do need to distribute that. So again, it doesn't matter which 2 points you pick, you should end up with the same equation for the line. So here's our equation again. Y minus 2 equals 3/4 x minus 3. Now I'm going to give you the same exact table, but this time we're going to write the problem in slope-intercept form, and we should come up with a similar equation. So we're starting out, we already know what the slope is. We know that the slope is 3/4, but I want to show you that it doesn't matter which 2 points that you use. So I'm going to do the slope again, but now I'm going to do it with 8, 5, and 12, 8. So, and it doesn't match, so I'm going to go 8 minus 5 over 12 minus 8. And if I'm starting with this 8 for the y coordinate, so if I'm going from left, or I guess this would be right to left, I have to go from right to left up here. I can't switch. I can't say 8 minus 5 and then do 8 minus 12, or the sign on my slope will be incorrect. So always do the same order, either right to left or left to right with both of them. So anyway, 8 minus 5 over 12 minus 8, x in the denominator. Sometimes students want to put x in the numerator and y in the denominator, but that's not going to give you the correct slope. Okay, now you see that the slopes match up. Now I need the y-intercept. So what I have to do is I have to use this to get my y-intercept. If you just write that down, y equals mx plus b, and then start filling stuff in. What we're looking for is b. We don't have it. This is what we want. And we have an x, we have a y, and we have a m, which is our slope. We already figured out the slope, so the 3/4 goes here. Now, for the x and the y, you can choose any x and y. I could choose 4, 2, 8, 5, 12, 8, 16, 11, so you just choose which one. I chose 4, 2. So now that means this is my x, this is my y. So now I know what y is, I know what m is, I know what x is. I can find b, which is what I want to find. So substituting those things in, y goes here. My slope is 3/4. X is 4. I'm looking for b. So when I multiply 3/4 by 4, this is just like multiplying over 1. I'll get 12 over 4, which is 3. And then I just move that 3 over to the other side, and I have b equals -1. When I'm writing an equation in slope-intercept form, I have to fill in the slope, I have to fill in the intercept, because the x and y will change depending on where I am on the line, but the slope and the intercept will not. So here's my equation for my line, y equals 3/4 x minus 1. Now I just want you to see that these are actually the same equation. Here they're similar, but point slope form looks like this. I'm going to move the 2 over to the other side, and then you can see that these equations are exactly the same, and they should be because they're the same exact line. Okay, you have a couple of equations to try for tomorrow.